Here is the exterior angles of polygons video. So I have some notes here at the top in bold. What's nice about the exterior sum of a polygon is there's no fancy equation for it. It just so happens that every single polygon, if you add up all their exterior angles, it will always be 360 degrees. Now let me show you why that is. So if I have a six-sided shape and I was to take a look at all these exterior angles, they will all add up, and here are the exterior angles, these out here. They will all add up. When I add up all six of these red angles, they'll add up to 360. Now, if I was to add twice as many sides to that, so now I have a 6 side versus a 12 side, as every object gets bigger, when I mean bigger, I mean more sides, you're going to start seeing what I call a pinwheel effect. As we add sides and exterior angles to an object, it almost starts to slowly pixelate it, meaning it's never going to be round, but it's slowly going to look more and more like a circle. So as I go up to 15, you should see it just a little better. So every polygon, no matter the size, all their angles will add up to 360. Now, if it's regular, if the polygon is regular and these three objects are regular, then that means from the last video, all sides and all angles are equal. To find one exterior angle, you just divide 360 by the number of sides, and that will get you 1, or each. Now, each is another word for 1. So let's look at these 4 questions and apply these 2 bold ideas. What is the measure of each exterior angle of a regular hexagon? Well, I don't really even care what this says. You can call it a hexagon, an octagon, 26-gon, 137-gon. What's the measure of each exterior angle of a regular hexagon? I'm always thinking 360 because it says exterior. So our equation for each, or 1, is this up here. So I'm just going to take 360 divided by the sides of this object. The hexagon is 6. So we're just taking 360 divided by 6, and you will get your 1. Grab my calculator real quick for you. 360 divided by 6 is 60. So the answer number 5 is 60. What's the measure of each exterior? I'm going back to this one right here. Of a 24-gon, 24 is my sides. 360 has to be the total because it's exterior. 360 divided by 24. This will have 15 sides. Now, we're going to use this equation a little differently now. So whoa, what happened? I'm going to get that to go away. I'm going to take a picture of this. All right, so here's my equation. If the exterior angle of a regular polygon is 12 degrees, now I want you to know that that's not a side. That's a measure. That's going to go in for 1. All right. How many sides does the polygon have? We're going to solve for n on this one. So my equation here is going to be 360 over n equals 12. Because 12, look, it even has a measure degree. This is not a side, this is a measure. So this actually means 360 over n equals 1 exterior measure. So how do I solve something like this? So if this is being divided by n, no matter what in all the equations I taught you, we always get rid of what's on the bottom first. And did you know that you can multiply both sides by a variable? So if I get rid of the n on both sides first, look what happens. No matter what is on the bottom, multiply that to both sides. So on the left, I have 360. On the right, I'll have 12n. Now, this equation you can solve. You just divide by 12. So 360 divided by 12, this object has 30 sides. So we could call that a 30gon. I'll erase that because I'll need that space here in a minute. So let's do that one more time. If the exterior angle of a regular polygon measures 40 degrees, that's a measure. So we're going to use this formula. And since it's a measure and we have to find sides, I can't put that in for n. This is going to be over here, just like the equation on the previous problem. If you have an equation like this, I call this a 2-tier, means 2 levels, and a 1 level. Always get rid of whatever's on the bottom of that 2-tier side. I just made that up. This is 2 sides and this is 1, so I call this 2-tier. We always multiply what's on the bottom, even if it's a letter. And now my equation is 360 equals 40n. Divide by 40, and this has 9 sides. And the top 4 questions are now finished. So let's go into a puzzle here. All right, so what you have here is you're just solving for x, so this will be a big, nasty equation. These are all exterior angles. So we would just add them up and make them equal to 360. I do not care how many sides it has. Since they're all outside, I'm adding them up to 360. Because back up here it says exterior sum of all polygons is 360. So in the previous video, I showed you these big, long equations. Now I'll show you how to write a smaller one, combining like terms as we go. So 4 and 7, I'm combining the x's. 4, 7 make 11, plus 5 is 16, plus 4 will give me 20, and another 9 gives me 20x. So I'll have 20 x's. So then I'm going to add the numbers. 1 and 4 make 5, plus 4 make 9, plus another 9 make 18, and this is a negative 6, so I'm subtracting 6. 18 minus 6 will give me a positive 12, and this is my equation for number 17. And then you just solve that, and if it only wants x, you're done. So let's look at some tough examples here. The reason why these are tough is because they mix in some things here. So what you need to do is stop sign in the shape of a regular octagon. Okay, regular octagon means all sides and angles are equal, and an octagon has 9 sides. All of you have seen this before. It's resting on a brick wall as shown in the accompanying diagram. What is the measure of angle x? This is an exterior angle. So we're interested in exterior sums. And I know this object. I can't believe I just said this has 9 sides. It has 8. I don't know what I was thinking. I hope I said 8, but it's 8. So it has the exterior sum of 360. It has 8 sides. What's the measure of this angle? We divide it by we use this equation, the measure of one exterior angle. We just divide 360 by 8, and that will give us x, 360 divided by 8. All right, so I want to make sure you see this. Now, you're going to see problems like this, all right? First of all, we have some new ways of telling you information on this diagram. So on this one, I pretty much want you to just define the measure of angle B, and angle B is down here. So we have exterior angles, so I'm thinking, well, that we got to use 360. It's easier. I want to use exterior angles, it's 360. And if these are marked the same way, as you can see in these three angles, that means you're really going to have three of the same, so I will have 3b here. So I'm building an equation, and I know I have 3b's. So then I have these three exterior angles taken care of. Now I'm going to focus on these three exterior angles, and I hope you catch what they did here. 68 cannot be included in this equation because 68 is inside. So you have to be careful and take your time a little bit. You have to find this, and it can be done with a linear pair right there. That's not too hard. And I can say what plus 68 is 180, so that has to be 112. The 112 is what you use. You do not use 68 in the equation. So my next step is to combine 69, 43, and 112 and put that number here. And then you can solve this equation and move on. So after you combine those three angles, it's pretty simple. Subtract and divide by 3. Number 3 is you have a choice. You can work with the inside of the polygon or outside. I think it would be extremely hard to work with the outside on this one. So what you can do is you're going to move what you can on the inside. This angle is outside. You can find its linear buddy here. That makes a half circle. This is 100. That makes a half circle, and you can do that here. This has to be, so whatever 180 minus 42 is, and that's 138. Okay, so you have to catch this when it gives you a combination of things. Now this is a 5-sided shape, and I'm working on the inside. So now I am not using anything with the exterior formulas. I'm using interior formulas, and that will give me my total. This is what we used on the previous equation. This will give me 540, and now I can build an equation because these 5 interior, I'm ignoring these 2 because they're not interior. These will add up to 540. So I have 2x and x make 3x. And 138, 100, and 110 make 348. I should make a plus 348. Equals 540. And that is the equation you can solve to find x. All right, on this one, I would use, if it gives you a combination of in and out, I would use the in again. Because I know I can find this interior angle here, that's 90. Because of the linear pair, I can do a half circle here and do 112. Now you cannot find angle D with using the inside of this 5-sided shape. Now I already used this 5-sided shape because I did 5 minus 2 times 180, got 540. So I know all this is 540. Would it be true if I took 90, 112, 98, 146 away from 540, I would get the last interior, not angle D, but the last interior angle. So 540 minus 90 minus 112 minus 90, 540 minus 90 minus 112, minus 98, and minus 146. That blue angle is 94. This is 86 because they have to add up to 180. So I take this 94 that I got, subtract it from 180, and I will have the outside angle. So there's your exterior angle problems up on top, and then some puzzle problems on the bottom.